Hello everyone, my name is Alexandre Gacon. I am working for Come2Camp as an architect, and so I am working for several years now on Terraform Provider for the GeoServer configuration management. So Come2Camp is a company which has been founded more than 20 years ago. We have more than 200 people working on open source software and not only on geospatial solution. We are on Switzerland, France, Germany, and we are now a subsidiary from the Swisscom group. Geospatial solution is composed by more than 60 experts in GIS and IT software. We are a member of OGC, of FOSS4GE, and also of Over2Maps Foundation. We are doing consulting, custom development. We are doing also maintenance hosting of open source solution and also doing training on this solution. We are user, contributor, committers, PSC member of several open source projects like GeoServer, GeoServer Cloud, GeoOrchestra, GeoNetwork, and so on. So let's start. Let's explain what is the GeoServer Terraform Provider. Who know Terraform or use it Terraform in the audience? Raise your hand. Some? Okay, thank you. So what is Terraform? Terraform is an infrastructure as code tool that you build, change, and version cloud and on-premise resources safely and efficiently. It was developed by HashiCorp. It is developed by HashiCorp, initially under Mozilla Public License, and has been changed to BSL. And as a consequence, there is a fork version which is called OpenTofu, and the provider is compatible with OpenTofu if you want to use it, if it suits you more your license policy. So why develop a Terraform provider compared to, for example, configuring manually by hand the GeoServer, or using existing Python client doing configuration with the REST API? We start to use a Terraform provider because first, in standard, Terraform manage references and dependencies between resources. That means that, for example, if you define a data stores in your Terraform file and you say that you have feature types which come from this data store in the Terraform configuration, Terraform itself, we know that it has to create first or update first the data store before trying to create, for example, the feature type. So it's in standard, you don't have to write the dependency with your, for example, in your Python script. Another cool thing is only updates and modified resources that are being detected as modified in the manifest, because Terraform is maintaining a state of the configuration. And when you ask to apply a new configuration, you will compare what you ask and what normally is expected in the configuration, and only do updates on what you need. So, for example, if you have 100 feature types and you have only one which has been shed, it will only update these feature types. It supports also variables. It supports secret injections. So it's quite safe also to work with secrets of database, for example. It supports templating. So for example, I have customer which generate style from building blocks using this templating feature. And you have also possibility to organize configuration into modules and to reuse more your configuration between different projects. So on GitHub, there is the code base is organized between two components: Go library, which is in fact a wrapper of the GeoServer REST API, which is called Go GeoServer. which it's separated because we would like to offer the possibility to use it into another project like Terraformer. I will come back to that later. And there is a provider itself, which uses provider the Terraform SDK and the Go library, glue them together to offer all the possibility previously mentioned. So some recent example, the project has been initiated for the Nexus system, which aims to cover the whole France firefighters department. We have a GeoServer configuration, which is quite rich with several data store, more than 100 layers, 100 styles. We have managed 4-layer groups, which are mostly base maps with a lot of layers in it. We are also using GeoWeb Cache for caching all base maps and also external WMS, for example, from IGN. We do continuous deployment for all match requests. So we have in development more than 40 environments in parallel that we need to update and create when the developer needs them. And we have also deployment on UAT and in production. So it means that when we have an update to do with the configuration, we have to update more than 10 environment. Some are being critical because we can't cut the service. So it's very critical for this mission. Just some example of what you can define as dependency. If you have on the right, for example, a workspace, we have defined in the workspace some GNDI data store. We also define a pre-generalized data store using the workspace and the configuration we have pushed into our server. We have different layers which are related to our data store, different style. We group them in a base map, and in the base map, we reference it in our caching system. So all this is defined as code with dependency. So we don't have to explicitly declare you need to create first the workspace, then the data store, and so on. We just have to describe how things relate together, and it is found out by Terraform how to do that. So what has been changed since last year? Current version is 0.0.25. We have added 5 new resources, 2 related to cascaded WMTS server, so the store and the layer. Also the capability to configure the WMS service of GeoServer, related to the new URL check rules. We have also resources to configure that as code, and also the capacity to configure the disk quota of GeoWeb Cache. So now we don't cover the whole capacities of the REST API of GeoServer for now. We cover only what our customer needs for the moment. So, but it's quite to have a lot of stuff. So we manage resource, the workspace, data stores, mostly database related one on Postgres with GDBC, GNDI, pre-generalized feature, SQL view. We manage feature type, style, and layer group. All WMS, external cascaded WMS, cascaded WMTS, configuration of security for URL checks and WMS service, and also GeoWeb Cache. So one of the regular complaint of my colleagues and of the customer, of people using the provider, is that even if we are not writing XML file, we are writing Terraform file. It's quite clumsy to write sometimes. You don't want to write so much. So I am ever trying to find a way to simplify the configuration. So there is nice stuff in standard into Terraform, which helps for that. So we'll see how we can do that, for example, with a for each meta argument. So the goal is that we want to expose easily in our GeoServer instance a library of style, which will be consumed by our main application. So it's not the main application will need to ask, for example, in WMS, a layer with a given style that we have in our library. And we want to reduce the effort to publish it with the Terraform configuration. So what are our tools? First, we have the for each meta argument, which create a resource of a given type for each occurrence in a map or in a set in Terraform. So for example, here we have an example. We want to create accounts, AWS IAM accounts. We have a list, and Terraform will pass this list and create and maintain the knowledge of this list. We have also the file set function, which easily provides a list of the file in a given folder matching regex. So the solution so this is an example of a resource of GeoServer style. So instead of writing a resource for each file in our folder, just to say this is a style I want to have in my GeoServer configuration, we can simply declare, okay, take all the CSS file, for example, in my subfolder, and for each, create a GeoServer style resource using the parameter I give you. And so it's with this simple declaration, we can handle as many. You just have to add new files into the folder to have Terraform able to create it in GeoServer. There is some limitation, of course. Since it's templating and not the resources are not correctly identified as a name, you cannot reference them in other resources, for example, to delegate the dependency resolution to Terraform. So, for example, you cannot say in a group that I need for my road layer the style, the style which is named by the resource, the Terraform resource style, road style. You can put the name, style for .css, for example, but you cannot use a Terraform resource to do the cascading. So, but you can at least force some kind of dependency by saying, for my group, I have a dependence on a style that you don't know, but that you can find later to create. So don't create the group before creating, for example, all the styles. We can also use the Terraform ecosystem to improve and simplify our configuration. For example, to use the database information without declaring all the tables you have in your database. So it's what I would like to do. For example, I want to automatically publish into my GeoServer instance all the tables I have on a Postgres database, or a set of tables, without having to declare them. So my idea was to do something similar to PG feature save or Martin or other PG-based application, for which they discover what you have in the database and automatically do the configuration for you. So our tools, we will use again the for each meta argument that we have seen just before, and we will use the ecosystem of provider to pick up another one, a Postgres SQL one. So this is the one named Cyril JDN PostgreSQL, which is a provider which can help to get information on the database. So, for example, if I want to have all the database and create feature types for all the tables, all I have to do is to declare first to get all the data to create a Terraform data saying I want you to declare to work on the database this one, which has been imported, for example, you can create with this provider. I want you to explore this schema. You can have a list of schema. And all you have to do is to say, I want you, using this template, to create and maintain feature types for all the table you find in this data. So like this, it helps you only have to create a new table in the schema to run Terraform again, and it will create or even remove, if you remove the table, it will update the configuration of the of GeoServer to match the content of your database. So there is still some limitation. So we cannot filter tables with geometry columns. It only it's quite simple. It only take all the table and view. You can find. You have the same thing for the view. You can find into the database, but you can play with some. If you have expression, you can use pattern to filter what you want. You cannot read the spatial reference system from the geometry column. So you, for a given data set, you have to say all this table will be, for example, in WGS 83. And also, it will only list the database, the available command. It won't give information on how the feature types, what are the columns in the database, and so it won't update automatically the feature type based on the database. But it helps to have some stuff easily. To finish, I would like to give also, I have some also colleagues and also people which ask me, okay, I would like, I am interested, for example, to migrate from GeoServer Vanilla to GeoServer Cloud, but I don't know to do how to do the migration of the configuration between two instances, or even keeping the same instance. I have difficulties, for example, to move my configuration from production to from staging to production, and I would like to be able to do some kind of synchronization. How could I do that? I don't want to. I would like to, or even I want to do the configuration on one master environment using the GeoServer UI, and I would like to be able to propagate it to other environment with a tool. So here comes Terraform integration. Terraformer, sorry. So Terraformer is a client command line tool which generates Terraform file from an existing infrastructure, which is any GeoServer Terraform-like infrastructure. So for GeoServer, it represents the capacity to translate the configuration done, for example, into the admin UI, into Terraform files, and like I said, to synchronize different environments, to do migration between platform, or to do migration between vanilla GeoServer or Cloud GeoServer instance. So how does it work? You execute a Terraform import command with indicating which resource you want to get. It will use an API to discover on the server what are the available resources. So luckily, we have a Go library to do that, so we can reuse that. And then it will use directly the Terraform provider to import the resource definition and give it to you. After, you only have to use the Terraform command with the generated definition to update another instance, for example. The only thing is that Terraformer does not generate resource dependency. So if you you have to manage them manually. So you have, for example, to say, I will do first the workspace, then the data store, then the feature type. But it will discover what you have done on server A, and you can, like this, do the configuration on another GeoServer. So there is first implementation I have done on a fork on our GitHub organization. It supports, for example, for the moment, workspaces, data store, and feature types. I have still some work to do to be able to support custom attributes in GeoServer feature types. The next step is to integrate the first version into the project, and then continue to add support for new resources like styles, layer group, and so on. And that's it for me. Thank you for your attention.